So let's go through the first question of the last video's challenge questions, which was duck, duck, goose. What you had to do here was go through an array of ducks, so just a bunch of strings that are either duck or goose. There would be a bunch of ducks and only one goose. However, there could be any number of ducks, and that goose could be in any position in the array. So your code that you wrote had to work no matter what we changed the ducks array to. So whether there was 1 duck, 1,000 ducks, 10,000 ducks, or if there was the one goose was at the start of the array, at the end of the array, in the middle, it had to work no matter what we changed that ducks array to. So how I would approach this question is I want to loop through all the items in the array to look for the goose, to make sure that I've checked every single one until I reach the goose. So when you're looping through an array, the quickest, simplest way to do this is usually a for loop. So let's write out the structure of that. So we have our parentheses and our curly brackets. So for loops let us really easily loop through all the items because we know where we want to start, because array indexes always start from 0, so we know always where to start at the start of the array, and we also know where we want to finish because we know we can easily find out how many items there are in an array, so we easily know when to stop when we loop through all the items. So let's set up our loop. We can start from I equals 0 because, as I mentioned, array indexes always start from 0, so we can start from 0 pretty confidently and know that we can access the first item in the array. Now, when should we stop looping? How about we loop as long as the index is less than the length of the array, because all these array indexes will be less than the length of the array because the array indexes just go up by 1 through all the array elements. So we can just have our condition as I is less than ducks.length. So this code will run as long as the index is less than the length of the array, so that is we're accessing an index of one of the items in the array. Now finally, how are we going to continue this loop? Let's just increment I by 1. So we're just going up by 1, checking each array element one by 1. So that's the bare bones of the structure of our loop. Now we just need to figure out what code we want to put in here. So we don't really want to print anything, we're not changing anything here, we're just doing a check. So how do we do checks or checking for certain things in code? We use an if statement. So let's write an if statement out. Okay. So what are we checking for? So if the item in the array is goose, then we found our goose. So how do we get an item of an element of an array? We just write the name of the array, then square brackets, and then because we're looping through all the items of the array, we're looking at ducks I because we don't know exactly what index we're looking at a certain point. We just want it to work for all the items. So because I is going to be changing through every time we loop, I is going to start from 0, and then it'll be 1, then it'll be 2, then it'll be 3. Then this ducks I, for each time we go through the loop, is going to be ducks 0, which is this, ducks 1, which is this, ducks 2, which is this, ducks 3, which is this, and so on. So ducks I will always be just the corresponding array element of that index, what I is at that given time, or that given iteration of the loop. So we're checking if ducks I is equal to goose. Cool, so then if this is true, if ducks I is equal to goose, then we want to print out the index. So console.log I. So now we want to print out something, which is the index as the question asks for. So I is going to be equal to the index as we have established. So this will only run once ducks I, so the array item that we're looking at in the iteration of the loop, it will only print out if it is goose. Let's run this. Cool, so we get 5. Let's check that goose is actually at index 5. 0, 1, 2, 3, 4, 5. Yeah, so the goose is at index 5. Now let's check our solution by changing this array a bit. So how about I move this goose, how about I move that to the start and see if that works. Run this again. Yep, it's still at index 0, so that's what we expected. It's the first item now, so our code still works. So if you change this array, change the number of ducks, move the goose, this code would still work. So by doing this check, doing a combination of an if statement and for loops, we're able to make this check happen no matter what the array looks like, because we're looping through all the items and using the index of the array to get a certain item and check it for each one of those items. Then we're able to print the correct index out every time.
So with our bigger challenge, we're going to take two numbers as input. We can just make them x and y, and if a number is bigger than the other, we'll print out the bigger one, and if they're the same, we'll print out the same. So we're going to use if and else statements, of course. So if x is greater than y, then we have to print out x, right? So we're going to console log x, and if, say, that one is not satisfied, well, otherwise, if x is equal to y, we might print out same. And if neither of these are true, then it only means one thing. That means that y must be larger than x. So we can console.log y. If you want to be really sure, you could do y is greater than x, but it's the only situation left, so we can just leave it as an else. So when we hit run now, we'll get 9 because 4 is bigger than 9. If we do a few more, minus 3, plus 4 and 3, well, we'll get 3. Things like that. Or we'll do one where they're the same. 5 and 5. Yep. So just remember how to write the if statements, put one after the other, and have the conditions. So for our biggest challenge, instead of just comparing two numbers, we're going to go through a whole array of numbers and print out the largest one. So to do this, we'll loop through every single number in this array. So we need the for statement and to initialize a counter, which I've called I. Then we're going to do it until it reaches past the end of the numbers array, which we're going to write by saying that I is less than the length of the numbers array. And we'll have to write the increment. So what happens at the end of every iteration. And inside here, we're going to need to compare and set a largest one. So we're going to need one from the beginning. So we'll call this the current biggest. And we're going to set this to the first element in the array because that will exist. Now, we're going to use the if statement inside our for loop. So for every element in our array of numbers, we're going to check if it's larger than the current biggest one. So if numbers I is larger than the current biggest, then we're going to replace the current biggest with the new current biggest, which is numbers I. After all this is done and we've checked every single number in this array, current biggest should hold the largest of the entire array, which lets us log it up. Biggest, which is the overall biggest. As you can see, we've gotten the highest number in every array. But what happens if we give a function an empty array as input? Is our bonus question. Well, JavaScript has handled that for us and written undefined, but we might want a bit of maybe a better way of saying this. So what we can do instead is check if the current biggest is equal to null, which is a word meaning undefined, then we're going to print empty array. This is just one way of dealing with it. Maybe you have a better way. And when we hit play, it'll say empty array, because when we set the current biggest to the first number in the numbers list well, there's nothing there, so it tried to point to something that didn't exist, which gives us nothing, null, undefined, and we've made it so that it now prints the empty array.
For this challenge, your function gets given an array full of strings that say either duck or goose. Your job was to return an array which had the same number of ducks in it, but got rid of all the geese. Gooses? Geese. We don't immediately know which array elements are ducks or geese, so we need to use a loop to check each item individually. So let's start by writing that loop. I'm going to use a for loop and loop through with the index of the array. So I'm just going to make a variable called I and equate that to 0. Then we want to loop through all the items in the array, so we can just keep looping until I is equal to the length of the array, so birds.length. Then let's just increment I by 1 so that we're getting every single item in the array. So that's our for loop. Then if we want to index into the array, then we just use birds, square brackets, I, and that gives us each of these elements in the array. Cool. Now, to determine whether we have a goose or not, we can use an if statement, where the condition is that the string of that item in the array is goose. Your first instinct here may have been that if this condition is true, so if bird's eye, the item in the array, is equal to goose, then we've just removed the goose. But this isn't the best idea because we need the original bird's array and its length to be intact in order to be able to loop through it without freaking out. It's like if someone started pulling out the rungs from a ladder while you were trying to climb it. So instead, as the hint suggested, we can make a new array to save our ducks into. This would be like, say, walking along a row of flowers and taking photos of just the flowers you like. Alright, so let's start by changing our if condition to, instead of checking that we have a goose, we can check that we have a not goose, which is the same in this context of checking if we have a duck. So if we have a duck, or not a goose, then we can add it to a new array. Let's just call that new birds. So let's make a new array variable, new birds, and start that as an empty array. Then if we have a not goose, then let's push that to our new array. Cool. So now that we're pushing all the birds we want, we can just return our new array at the end. Alright, let's test. Awesome. So even though we gave our functions a bunch of geese, we're only printing out the ducks. Looks like we've cracked the code for this one.